All right, so today we are going to do setup of word problems. We have two-step equations and then variables on both sides. So let's start with two-step word problems. So here is the guidelines of what you should probably do. You're going to read and then reread the problem. Got to read it twice. You're going to identify what you know and what you don't know. And what you don't know is your variable, okay? Underline it, write it out, whatever. Identify the total. This can be difficult sometimes, so just be careful. Logically set it up. It's a two-step equation, right? So that means we should have a coefficient with our variable, a constant equals, and then that total. And then you're going to solve and answer the question. Now today we are just going to set it up for the sake of the time within this video. So before we begin, why don't you go ahead and read through this. Now, what we're going to do is we're going to read it again, but we're going to list out what we know and what we don't know. And I know this is a two-step equation because it's only talking about one person. It's not doing any comparing. So Emily lost half of all of her hats. So that's information, that's numbers. She lost half of all of her hats. So we know she lost half of all of her hats. And then it says a week later, she bought 5 more. And then it says now she has 13 hats. Of these 3 things, one of the total is losing half the total, buying 5 more the total, or now having 13. Now having 13, this is your total, okay? And then how do you know what you don't know? Well, it's in your question. With how many hats did she start? So we know it's going to be hats, so we're going to use H for hats that she started with, right? Well, this is the total, so I can't do it. So is buying 5 more part of having the hats or losing half the hats? Buying 5 more is a concrete thing that's not going to change. Losing half of your hats, we don't know how many she started with, so that's where the H is going to go. Therefore, this equals 13 is going to be by itself because that's the total. She lost half of her hats, so this is where you got to be careful, okay? You can write it as 1/2 times H, but more than likely you're going to see it as H chopped in half. She lost half of her hats. Buying 5 more is an adding thing, right? You're getting more, you're adding. So this is going to be the equation you will solve, okay? And I would solve it. Next problem on the next page. We already know, because this is two-step stuff, what we know, what we don't. Read the question. All right, so we know she had $25 to spend on, oh, look, another number, 8 notebooks. 8, I'm going to abbreviate that as notebooks, right? After buying them, she had $9. And then our variable is how much did each notebook cost? So that's my question. So we don't know the price of notebooks. We'll put N. We'll put N for notebooks. Okay, so she had $25. Let's figure out the total. She had $25. She bought 8 notebooks, and then she left with $9. Now, this one you got to be careful with. $9 would be your total. You went into the store, you bought the things, you came out of the store. This is what you got when you're done. That's your total. So I'm going to put equals $9. Okay. Now, logically figure out between these two, who's going to have the variable. Having $25 or 8 notebooks. Well, we don't know the cost of those notebooks, so that's where the variable is going to go. So when I logically set this up, I can do 25. That's what I started with. Then I'm going to spend money. And if you spend money, well, you're not going to have more of it. You're going to have less of it. And that's where my variable N is going to go with this problem. And there we go, set up. Had the money, spent the money on 8 notebooks, money you got when you leave. Go ahead, take a moment, read the problem about Marcel. So, of what I know, which one's my total? Paying $43. That's how much all said and done when he's done riding that bike. The variable is going to go with $5 an hour. It even has the word hour in it. Look at that. So when I set this up logically, you pay 18 bucks and it already said plus $5 an hour. And that's where I'm going to attach the variable is with this H. So that is the end of this problem. Variable on both side word problems. Read, reread, identify the two sides. Key word to know it's a variable or a problem with variable on both sides is this word same. Every single time you will see that word same. All right. Identify what you know and what you don't know. Again, what you don't know is your variables. Each side is set up similar to a two-sided equation. So it's like doing two of those of what we just did at once. The equal sign goes in between those two sides, and then you solve an answer. Again, we're just going to set up in this video, but you should solve the equation. All right, so we got Miss McDonald, Miss Juskunas are participating. All right, so go ahead and read this problem and get it set up. So in this one, we are going to start with the question. When will they have the same number of laps? Well, first off, there's that word same, so that's how I know it's a variable on both sides. Number of laps completed, right? So we're going to use L for laps. That's going to be our variable, and I use a pretty fancy cursive L. All right, so we are comparing two sides, right? Now you're identifying what you know and don't know. So we are talking about Miss McDonald and we are talking about Miss Juskunas, okay? What do we know about Miss McDonald? Well, I'm sorry, we start with Miss Juskunas. We already know she has 13. So she already has 13. She walks one lap during each of her planning periods. And that's all we know. Then we got Miss McDonald. Miss McDonald has 7 laps and she walks 2 laps each planning period. Well, I know my variable lap L for laps is going to go with this 2 laps each planning period, this 1 lap each planning period. So I'm going to logically write this out. So she's going to have 7 plus 2 because she's increasing the amount of laps she does. So this is Miss McDonald's. Miss J's is going to go 13 plus 1L. And we're asking about when they are the same, so that is where my equal signs go, and ba-da-ba, done. All right, read this next one. All right, the question, when will they have the same amount of money in their account? So I'm going to do M for money. All right, we are talking about two different people. We are talking about Kennedy and we are talking about Amarian, both amazing former students. All right, so Kennedy has negative $1. How rude. All right, and we know she earns $3, each day. So earns $3 each day. Amarian has negative $3. You guys need to spend your money better. But his saving account accrues him $5 each day. Now, our question is asking when will they have the same money in their account. So if you earn money and accrue money, this is where your variable is going to go, right? Every day you're making some more money. That's supposed to say earns. Jeez Louise. So let's logically set up each side of the equation. She has negative $1, but she earns $3 each day, and that's where my variable is going to go. Amarian has negative $3, but he accrues $5 each day, and that's where his variable will go. Because it's the same, we set them equal to one another. Bada boom. Solve it. Last one. Go ahead, read it. Okay. So let's look at our question first to figure out our variable. When will they have the same, there's that word same, number of worksheets? So let's do W for worksheets. So here we go. Let's logically set up these equations. She already has 15 plus 6 more per minute. So we're going to put W for those worksheets she does. And then Mr. Pascas already has 55 plus 2 worksheets per minute. So that's where we're going to put that W. So that one question in these last 2 problems told us where our variable was going to go. So there we go. Then we had that word same, so I know I set these equal to each other, and bada boom, we are done. This can be glued. Sorry it was a longer video, but there was reading, and it's a word problem. All right, good luck. Have a great day.